My name is Kyle Spencer. I'm the GIS Team Supervisor with the City of Norfolk Department of Communications and Technology. For the Esri App Challenge, we'd like to submit an app called Titan, which is the Tidal Inundation tracking application for Norfolk. Before I jump into the app, I'd like to explain a little bit about what went into it and how it will help our city continue to be resilient with the changes in climate, specifically sea level rise. So after joining the National Flood Insurance Program in the late 70s, the city in the early 90s dedicated funding towards managing stormwater. And in 2007, a coastal flooding study was started by putting in tide gauges in various parts of the city and developing a predictive model based on what those gauges were reading and the NOAA gauges in the area. In 2013, the city of Norfolk was recognized by the Rockefeller Foundation as a resilient city. It was one of the first 33 out of 100 that the Rockefeller Foundation is working with on continuing those efforts. So the flood risk in Norfolk is a very high one. It's a low-lying area and surrounded by water. About 13% of the city is in the FEMA 100-year flood zone or 1% annual chance flood zone. There's a lot of reasons why the city of Norfolk floods. Some of the contributing factors are geologic processes. Historical development is also an issue where folks have gone in and built on top of old creek beds, and those are areas where we see a lot of the flooding today. So the NOAA's tide gauge is been around for a long time, and you can see from this graphic that the sea level rise is occurring quite rapidly. It's actually one of the highest rates anywhere in the United States. So this presents a lot of challenges for the city of Norfolk. So what happens is more increased nuisance flooding occurs around the city. It could be a clear day, doesn't have to be a storm, and you get flooding in the streets. Major storm events occur more frequently and have higher water levels, as this graphic shows. You can see on the right-hand side here, there's a concentration of major water levels from Sewell's Point. So the city installed tide gauges in strategic areas around the city to develop a model based on what Sewell's Point was reading, and Titan has taken that predictive flood model into account. And so I'd like to show you the app now. Basically, we're reading the values from Sewell's Point from a web service that NOAA has, and based on that value, the application will turn on the appropriate flood layer. So I'll just zoom in a little bit here so you can see that right now in the label up here you can see that is it's a low tide, so there's the 0-foot flood layer, which looks like there's a little flooding. If you zoom in, it's just some wetland areas showing up as flooded. So the user can pan around and zoom and look at what the current value is at Sewell's Point and see what that looks like during a major storm event or something like that. Also, the user can come in and just turn on another flood layer in 6-inch increments to see what that would look like, and pan around and zoom around the city and visually analyze what the effect would be. We've included some critical facilities in our map here, things like emergency shelters and hospitals. So if during a storm event, hopefully folks can use this application to navigate themselves to those types of facilities and avoid water. The user can also fade out flooding layer just to see through and look at the aerial. So that's what that looks like. And um, we've also added a couple other buttons down here at the bottom. If you click on this first one, Sewell's Point gauge, you can see what the latest reading is, the observed water level, and the rounded to the nearest half-foot increment, what flood grid that would be. We've included links to NOAA's website for graphical representations of the tide curves, 1, 3, and 7 days out. We've also included links to what the tide curves look like during a few major storm events in the area. One was Isabel in 2003, and you can see it dropped way off as the tide went out and the storm moved on. In contrast, the 2009 nor'easter, the tide stayed high for several days, which caused a lot of issues with flooding and keeping people from accessing some of those critical facilities, as I mentioned before. So we included some hyperlinks here on this page for that. We also have a link here to NOAA also does forecasted surge predictions, and this is very useful during a major storm event. So you can see all the raw data here, but if you'd like, you can also see we have a hyperlink to their website showing what the graphical representation looks like for that. And then if the user would like to go back to what the current value is at Sewell's Point and refresh the map, you can just hit this button here, current elevation, and it puts you back to the home extent and turns on the correct flood layer based on the tide reading. So that's the application now. We have naturally have plans for the future development. The city is going to reinstall the gauges and connect them to the internet so that we can feed those into the application. We're also hoping to use this, like I said, to model major storm events as they happen. We'd also like to use this to strategize mitigation options around the city, and we would also like to incorporate other layers such as flooded streets and things like that based on what the tide gauges are reading. And continue to work with our other partners on this in the Norfolk's flood strategy team. And some of the folks involved with that are in this list here. As I mentioned before, we met with Code for America and we're working with them to develop the app more and other applications. We worked with them recently at the National Day of Civic Hacking this past Saturday, and continuing to work with the Rockefeller Foundation on coordinating our efforts with them as well as other cities that face similar challenges. And thank you for this opportunity.